Okay, so let's begin solving radical equations by talking about inverse operations. What's the inverse of addition? Subtraction. What's the inverse of a negative sign? A positive sign. What's the inverse of multiplication? Multiplication. What is the inverse of squaring something? A square root. So what's the inverse of a square root?
Squared.
Something squared. You don't need to. Okay, so let's use this idea of inverse operations for solving radical equations. So, the square root of y equals 4. Can I simplify this in any way?
Yes.
Can I solve it? Can I do anything with it?
Yes, ma'am.
What can I do with it? Well, but before, other than squaring both sides, is there anything else I can do with it?
No.
Okay, that's the first thing you have to ask yourself. Can I do anything with it other than squaring both sides? So no, I can't do anything with it other than squaring both sides, so that's what I'm going to do. I'm going to square both sides of my equation. When I square a square root, it cancels, right? Because I now have y squared underneath the square root, correct? So we all know how to do that. So when I square this square root, I just get y. Y equals what? 16. For every single problem, I want you to check it. If you don't check it, you're not going to get full credit. Andrew, what did I say? No, that's not what I said. If you don't check it, you're not going to get credit for your homework, okay? All right, so when I check it, I just substitute the value back in. So if the square root of y equals, see how I'm substituting y back into my equation? This one's an easy one. Square root of 16 should equal 4. Is the square root of 16 4? Yes. So it checks. Let's do number 2. Is there any way, any operations that I can perform other than squaring both sides? Nothing? Nothing I can do to both sides, right? So I'm going to square both sides. When I square a square root, I just get y. Now here's what I'm talking about. This seems so easy that you could overlook the fact that you also need to, you need to square everything in the parentheses, correct? So don't I have to square that 3? So 3 squared is 9 times the square, if I square the square root of 2, what do I get? 2. So y equals 18. Let's check it. If I substitute 18 in for y, does that equal 3 root 2? Well, let's see. Get rid of that. Is there a square in 18? Yes, 3 squared. Times what? 2. So the 3 gets kicked out, and they equal each other. So yes, it checks. Is there anything that I can do to this?
Yes.
What? Yes. Explain what? I'm doing the inverse of a square root, which is a square. See this one, how I squared? I can do anything to any equation as long as I do the same thing to both sides, right? And this is why, because if I take this right here, square root of y, and I square it, isn't squaring me multiplying it? Right? See that? And y, square root of y times the square root of y is the square root of y squared. And when you have a square underneath a square root, you kick the y out. So every single one of these, that if I square it, it just cancels the square root. Okay? All right, so this one, when I square it, Vanessa, what's going to happen? When I square this one, what's going to happen? Yeah, so what will I have left over? No. Negative 2x, right? When you square it, you're canceling the square root. See it now? So negative 2x equals 64. This is another big problem. You'll see it and you'll be doing it so fast you'll forget to square the 8. Can you see yourself making that mistake? Possibly. When I divide both sides by negative 2, I get x equals negative 32. Let's check it.
So why do you want to check it?
Because there are extraneous solutions. Okay, so I'm going to check it. Negative 2 times negative 32 should be equal to 8, correct? What is negative 2 times negative 32? Positive 64. All of the checks will be easy because the work is already in the problem you just did, right? So is the square root of 64 8? It is indeed. Check. What happens if you don't do the checks? No credit. Just making sure. How many people do you think are going to complain about that on Wednesday when they don't do the checks and I don't give them credit? A lot? Okay, so I can't do anything with this, so I just have to square both sides. When I square this side, I get negative x. When I square this side, I get 100 times 7. So if negative x equals 700, then x equals negative 700. Let's check it. Square root. I've got a negative sign here. Then I'm going to substitute in my x. That should be equal to 10 root 7. A negative times a negative is a positive, and 700 can be written 7 times 100. Do they check? Yes, because I can kick out that 100 because it's 10 squared. So it checks. Question? Okay, clickers. Let's put these in our clickers. So let's talk about extraneous solutions. Why, can somebody tell me by just looking at this, why this has no solution? Anthony? It is because it's negative, but why? No. Elton? It's not going to equal 0.
Or because when you divide, it would be like, let's not do it that way.
When you have a square root, Anthony, you think you got it?
Is it because x plus 2?
Well, it's because no matter what, if I take the square root of something, do I ever get a negative number? This is saying this has to be equal to negative 5, right? No matter what's in here, if I add 3 to it and take the square root, is it ever going to be negative? No, it'll never be negative. So let's do this one. How would I solve it?
Square.
Square both sides, right?
Wait, I get confused when you say, is there anything else?
You'll see in just a second. When I square a square root, the square root falls off, right? So what am I left with?
X squared plus 9.
No.
X plus 3 equals
X plus 3 equals positive 25. That's right there the reason that this doesn't work, because I just squared a negative, and so the negative went away. So when I subtract 3 from both sides, I get X equals 22. If I put 22 back in here, right, substitute it back in, plus 3, it should equal negative 5. What is 22 plus 3? 25. What is the square root of 25? 5. Does 5 equal negative 5? No. So this is an extraneous solution. So 22 does not work. Okay? If it was positive 5, then it would work. Very true. Okay, so let's do this one. I can't do anything to it, and so I'm just going to square both sides. When I square the square root, I'm left with 3b minus 6 equals 36. Now, we just do all the inverse operations, right? If I've got, see how every single thing we're doing inverses of. So if I have negative 6, I'm going to add 6. Then I get 3b equals 42. I don't know why I wrote 36. 3b. Now I'm going to do the inverse of this. If I'm multiplying, I'm going to divide. So b equals 14. Let's check it. If I substitute 14 in for b and subtract 6, will I get 6? Well, what's 3 times 14? 42, because we already did that. And what's 42 minus 6? 36. And what's the square root of 36? 6. So it checks. Patrick, is there anything I can do to this before squaring both sides? How? Bring it over. How do you bring it over? Good. Take the inverse. Now I have 3 times the square root of b equals 12. Is there anything else I can do? There's still something I can do. I can divide by 3. Now I have the square root of b equals 4. Now there's nothing else I can do, so the last operation I'm going to perform is square both sides. When I do that, I get b equals 16. Let's check it. 3 times the square root of b, which is 16, minus 6 should equal 6. 3 times, what's the square root of 16? 4 minus 6. 3 times 4 is 12 minus 6. 6 does equal 6, so it checks. Questions? Let's try this one. Is there anything I can perform before I square both sides? No. When I square this, I get x over 2 plus 7 equals 81. Now what do I do? Subtract 7 from both sides, and I get x over 2 equals what? 74. What's the last thing I do? I have division, so I multiply. 74 times 2 is 148. Let's check it. If I have 148 and I divide it by 2 and I add 7 and take the square root, will I get 9? 148 divided by 2 is what?
74.
74. We have the answer above us. 74 plus 7. And 74 plus 7 is 81. Does it check?
Yes.
It checks. Can I do anything with this? I can subtract 7 before I do anything. When I subtract 7, I get the square root of x over 2 equals 0. So x equals 0. When I plug that back in, this one's pretty easy to see, right? 0 over 2 is 0, so does 7 equal 7? Yes. That's the 7-minute bell. I'd rather give you guys some time to do work, so instead of putting this in our clickers, why don't we just end there? Good job.